Imagine flights that are faster, more efficient, and dramatically greener. The Rolls-Royce UltraFan and CFM's Rise Open Fan are set to revolutionize aviation. Join us as we explore how these groundbreaking engines will transform the future of air travel. Ever wondered how a new engine design can slash emissions and fuel consumption? Now, the CFM International Rise engine is a groundbreaking project that promises to revolutionize the future of aviation. Developed by CFM International, a joint venture between General Electric Aerospace and Safran Aircraft Engines, this open rotor engine is set to make big strides in sustainable aviation. The Rise engine is designed to use both hydrogen and sustainable aviation fuels. It aims to cut fuel consumption and carbon dioxide emissions by 20% compared to current engines. That's a bold promise, and it's exactly the kind of leap aviation needs to make if we're serious about fighting climate change. But what makes Rise so special? For starters, it represents a major shift in aviation propulsion technology. CFM is not just tweaking existing engines, they're developing something entirely new that could set the standard for the future. The goal isn't just to improve on the tried and true CFM 56 and LEAP engines, but to lay the groundwork for even more advanced technologies that will drive aviation into the next generation. To put it simply, achieving a sustainable future in aviation demands more than incremental changes. It requires a propulsion system capable of delivering the biggest reduction in CO2 emissions we've ever seen in this industry. The new standards for noise and emissions set by the International Civil Aviation Organization will be tough to meet, but CFM is rising to the challenge. Since the early 1980s, CFM engines have already cut fuel consumption and CO2 emissions by 40% thanks to continuous innovation. The Rise engine aims to build on the success with its open fan architecture, which could push reductions in fuel use and CO2 emissions even further by more than 20% compared to today's most efficient engines. Could a new engine design really transform air travel as we know it? CFM International is on a mission to explore various engine designs, each with its own set of challenges that make it difficult to achieve the full 20% improvement in efficiency they're aiming for. The goal is to find an architecture that maximizes propulsive efficiency while meeting aircraft development timelines and performance standards. The Rise program is at the forefront of this exploration. It's showcasing foundational technologies that will help CFM identify the best engine design to hit those ambitious efficiency goals. With over 1 billion hours of operational experience, CFM has had an unparalleled understanding of what works and what doesn't. Their engines are widely recognized as industry benchmarks for reliability and performance. Among the different designs, the open fan architecture stands out as the most promising. This approach offers a significant leap in propulsive efficiency, which is crucial for achieving the desired 20% reduction in fuel use and emissions. It also promises improvements in thermal efficiency and the integration of advanced systems that could redefine aviation standards. Looking back at aviation history, we see that major efficiency breakthroughs often came from adopting new technologies that allowed for larger fan sizes and higher bypass ratios. Essentially, to maximize fuel efficiency, an engine needs to move a lot of air while minimizing the speed at which it's expelled. This principle has driven the growth of engine fan sizes over the past 50 years and is now leading us toward open fan concepts. What if the next generation of engines could operate at the speed of current jets, but with far less environmental impact? The open fan architecture in the Rise program differs significantly from the turboprop engines used in slower regional aircraft. Unlike those, the new generation open fan engine is designed to operate at speeds comparable to current single-aisle jets, up to Mach 0.8 or 80% of the speed of sound, while meeting future noise regulations. This innovative design represents a major step forward in creating a more sustainable and efficient future for aviation. CFM International is heavily investing in the development of advanced technologies for their Rise program, with a detailed plan that includes over 300 tests on components, modules, and full engines. This rigorous approach is designed to refine and mature these technologies. One major area of advancement is the use of carbon fiber composite fan blades. Since the GE90 engine's debut in 1995, CFM has pushed the boundaries of fan blade technology, leading to highly efficient and durable composite blades that have accumulated over 140 million flight hours. These are the only carbon fiber blades in commercial use and have the advantage of not needing a life limit, making them a crucial component in the drive toward greater efficiency. Hybrid electric propulsion is another exciting development. By combining gas-powered turbines with electric motors, CFM aims to lead the industry in hybrid electric technology for single-aisle aircraft. GE and Safran are particularly well positioned for this thanks to their extensive expertise in electrical engineering, manufacturing, and advanced materials research. Can the fuel of the future really be sustainable and efficient enough to power the next generation of aircraft? On the alternative energy front, CFM is exploring the use of 100% sustainable aviation fuels and hydrogen. They've been testing SAF blends since 2006, and many commercial flights have used these blends. The company is also working to certify 100% renewable fuels, which could significantly reduce CO2 emissions if global supply chains support their widespread use. GE and Safran aircraft engines are deeply invested in advancing aviation technology. Their commitment extends beyond just developing new engines. They're actively participating in research programs supported by government funding to ensure that groundbreaking technologies reach their full potential. For instance, Safran aircraft engines and Avio Aero are key players in the Clean Aviation European Research Program, which runs from 2022 to 2028. This program is crucial for testing new technologies through ground and flight demonstrations, pushing the boundaries of what's possible in sustainable aviation. Similarly, GE Aviation is collaborating with NASA and the Federal Aviation Administration on the CLEAN program, focused on reducing energy use, emissions, and noise in aviation. Both GE and Safran also have strong global partnerships with various national governments to further technology development. Integration with aircraft manufacturers is a critical aspect of the RISE program. To fully realize the potential of these new technologies, close collaboration with aircraft builders is essential. The advanced open-fan engines being developed could be installed in several ways under the wings in either low or high wing configuration or mounted at the back of the aircraft. This flexibility allows for optimizing the performance of these engines in different aircraft designs, ensuring that they deliver the best possible efficiency and environmental benefits. How important is collaboration between engine developers and aircraft manufacturers in achieving advancements in aviation technology? What will it take for the aviation industry to truly become sustainable? The aviation industry faces a significant challenge when it comes to sustainability. In 2019, aviation was responsible for emitting 915 million tons of CO2, making up about 2% of total human-induced CO2 emissions. Despite this relatively small percentage, the industry is growing rapidly, and without major advancements, carbon emissions from aircraft traffic are projected to triple by 2050. To combat this, the International Air Transport Association and other industry stakeholders have set ambitious targets. They've aimed for a 1.5% annual improvement in fuel efficiency from 2009 to 2020, a goal that has been achieved. Moving forward, they have committed to capping net aviation CO2 emissions from 2020 onward and reducing net aviation CO2 emissions by 50% by 2050 compared to 2005 levels. Meeting these goals will require numerous technological advancements, and the industry is exploring even more ambitious requirements to ensure long-term sustainability. Looking ahead, CFM International is already engaging with aviation authorities to address the certification and regulatory requirements for new open-fan engine technologies. They're committed to supporting the development of new certification methods as needed, ensuring that these technologies meet all necessary standards. Could a new engine design make your next flight more sustainable and efficient than ever before? Now, Rolls-Royce, famed for its luxury and high-performance engines in both cars and planes, is shaking up the aviation world with its new engine, the UltraFan. This revolutionary engine is set to replace the engines on popular aircraft like the Boeing 737 and Airbus A320. But you might be wondering how such a massive engine can fit on these smaller planes, which are the backbone of commercial aviation. The secret lies in the technology of the UltraFan, which Rolls-Royce is adapting for smaller engines suitable for these narrow-body aircraft. So how will the UltraFan revolutionize the aviation industry? In mid-November 2023, Airbus made history by running the Rolls-Royce UltraFan at full power. This enormous engine with a diameter of 140 inches surpassed the previous record held by General Electric's GE9X, which has a diameter of 134 inches. At Rolls-Royce's Testbed 80 facility in Derby, UK, the UltraFan reached its peak power, producing an astounding 64 megawatts and over 85,000 pounds of static thrust. Rolls-Royce even claims that the thrust can reach up to 110,000 pounds mid-flight, making it suitable for both narrow-body and wide-body aircraft. What makes this test even more significant is that it was conducted using 100% sustainable aviation fuel, marking a major step towards greener aviation technology. The successful use of SAF not only shows UltraFan's advanced capabilities, but also displays Rolls-Royce's commitment to sustainability. Moreover, Rolls-Royce has proven that all its engines are compatible with SAF, reinforcing its position as a leader in eco-friendly aviation technology. What sets the UltraFan apart from other advanced engines, and why should we care? Since the UltraFan's test earlier this year, Rolls-Royce has been steadily increasing the engine's power as part of a meticulous testing process. The results so far have met their expectations, and the data gathered from these tests will provide valuable insights for future developments. This engine, designed to be more efficient than its predecessors like the Trent XWB, the world's most efficient large aero engine, is set to transform both current and future aircraft propulsion systems. Developed over a decade, the UltraFan was first unveiled in 2014. Unlike the 4,200 large civil engines currently in service from Rolls-Royce, the UltraFan introduces a completely new design. It features a larger, more advanced geared system than any competitors, allowing for greater efficiency and performance. The engine's design includes options for 2-shaft, 3-shaft, direct drive, and geared systems, providing flexibility for different aircraft requirements. A key component is its 50-megawatt power gearbox developed at Rolls-Royce's Dahlhausen facility in Germany. This gearbox helps manage power more efficiently. Advanced materials and technologies are integral to the UltraFan's design. It incorporates a composite fan system, hybrid ceramic bearings, and ceramic matrix composites. The composite fan system is lighter and more durable, while hybrid ceramic bearings and CMCs withstand extreme temperatures and pressures inside the engine. These materials were previously tested in the HT3 demonstrator based on the Trent XWB-97 engine, ensuring they perform well under the UltraFan's demanding conditions. Is it really possible to achieve net zero aviation by 2050? And how does UltraFan contribute to this goal? Tufan Ergin Bilgic, CEO of Rolls-Royce plc, talked about the significance of this achievement, noting it shows Rolls-Royce's leadership in aviation innovation and its commitment to sustainable solutions. Simon Burr, Group Director of Engineering, Technology and Safety, emphasized that next-generation engines like the UltraFan will be crucial for achieving net zero flying by 2050. The UltraFan's development has been supported by various organizations, including the UK government, the Aerospace Technology Institute, Innovate UK, the EU's Clean Sky programs, LUFO, and the state of Brandenburg in Germany. What role will government and industry partnerships play in achieving the ambitious goals for sustainable aviation? The Rolls-Royce UltraFan is turning heads with its groundbreaking design and impressive specifications. This next-generation engine features a geared turbofan with a variable pitch fan system, allowing it to operate at peak efficiency by adjusting the fan and turbine speeds. Its fan blades make the UltraFan about 10% more efficient than the Trent XWB, a major leap in performance. The UltraFan also achieves a 25% improvement in fuel burn compared to its predecessor, setting a new standard for efficiency. But how does the UltraFan compare to its rivals? Pratt & Whitney, for example, has made waves with its geared fan technology in single-aisle aircraft, while General Electric and CFM International are developing their own advanced engines with geared fan designs and open fan architectures. Both of these competitors are incorporating advanced ceramic matrix composites to enhance efficiency and handle higher temperatures. Could scaling down advanced engines like the UltraFan be the key to revolutionizing narrow-body aircraft? But Rolls-Royce's unique edge comes from its innovative three-spool jet engine design, which divides the engine into 3 sections, each optimized for different flight conditions. This approach offers exceptional flexibility and efficiency across various phases of flight. The UltraFan's variable pitch fan system, which adjusts blade angles for optimal performance, and its lightweight carbon composite fan blades set it apart from the competition. In terms of technology, the UltraFan utilizes a 3-spool design with multiple concentric shafts, allowing different engine parts to rotate at their ideal speeds. This setup, combined with a new lean burn combustor system, reduces emissions by burning fuel more efficiently. Recent tests in May of 2023 showed the UltraFan achieved a pressure ratio of 70-1 and a bypass ratio of 14-1, surpassing the Trent engine's ratios of 50-1 and 10-1. Rolls-Royce's challenge is now to scale down the UltraFan for smaller aircraft like the Airbus A320 and Boeing 737. While this miniaturization process will take time, the company's strong financial position and successful development of the UltraFan suggests they are well positioned for future success. Now, which engine do you think will have a bigger impact on the future of aviation, the CFM Rise or the Rolls-Royce UltraFan? Thanks for joining us on this gripping journey through the advancements of the CFM Rise and Rolls-Royce UltraFan engines. But hey, the excitement doesn't have to end here. If you enjoyed the ride, subscribe for more thrilling tales and feel free to share your thoughts in the comments below. And before you go, make sure your seatbelts are fastened and tray tables are up. Safe travels and happy subscribing.